India is blessed with abundant solar energy, where most parts get more than 300 sunny days per year. Solar energy thus has a great potential for India. Based on this vision, Government of India launched the Solar Mission to promote sustainable growth of solar industry. This has created a huge demand for skilled manpower in all areas of solar energy. IIT Bombay, being the premier institute for engineering education, was chosen to lead the efforts in developing this workforce.
Solar photovoltaics is playing a major role in the decarbonization of India's electric grid. IIT Bombay has been at the forefront of the PV research for over a decade and has the largest and most active group of faculty members in India working in various areas of PV. NCPRE has played a major role in anchoring and accelerating the PV research at IIT Bombay. The institute has also supported NCPRE with significant amount of lab space and manpower. Considering the fact that India is set to become a major PV manufacturing hub in the next 5 years, there is an urgent need for trained and skilled manpower in this area. Manpower training has been an important aspect of NCPRE, and it has trained thousands of engineers in various aspects of photovoltaic technologies over the years. The institute is committed to support the R&D in PV and has recently created a photovoltaic technology and innovation center to support the broad PV activities at IIT Bombay. NCPRE will be an important part of this initiative.
It was established in 2010 by the Ministry of New and Renewable Energy, and in little over a decade, it has emerged as one of the leading centers in the world which carries out cutting-edge research work in the area of solar PV. Its success is attributed to the teamwork and coordinated efforts of hundreds of staff members, both research and administrative, research scholars, and over 30 faculty members from 9 different departments. Being in IIT Bombay, it is one of the few R&D centers in the world where a broad range of expertise in PV and allied technologies is found under one roof. Our areas of expertise include silicon solar cell fabrication, perovskite and tandem cells, module reliability, PV plant evaluation, wide bandgap based power electronics, energy storage, and design of magnetics for inverters and motors. We are working very closely with industry and government agencies to provide R&D support in rapid transition to PV in our country.
There has been a significant increase in the solar PV deployments in the country in the last decade. This has led to a huge demand for skilled personnel in the country. Additionally, due to the recent announcement of PV manufacturing mission and aligned government policies, we strongly believe that this demand for skilled personnel is going to be much more. Over the last decade, as part of our capacity building activity, we have conducted several training workshops from basic to advanced for both industry and academia. At NCPRE, we design our programs to cater the requirements of India's growing solar PV industry.
In the last decade, NCPRE has done pioneering field studies in the area of PV module reliability, and we have found that the modules deployed in hot climates degrade at significantly higher rates than modules in moderate and temperate climates. As we move to phase 3, we plan to continue doing these field surveys of module reliability with an expanded focus to include the structures and other balance of system components, and also an emphasis on the degradation modes in new PV technologies. We also plan to set up a large joint field test site where the degradation modes in new PV technologies could be discovered rapidly, and we could also accelerate the technology readiness level of various innovations in PV by collecting valuable field data of these different technologies. NCPRE has also developed several PV diagnostics and test instrumentation up to technology readiness level of 7, and we plan to push these further towards commercialization in this phase. Moreover, we plan to create open domain datasets in the area of PV performance that are required for training AI and ML algorithms for PV forecasting, as well as automated operation and maintenance of large power plants. And as always, we plan to work closely with industry in all of our activities in this area.
The real potential of solar energy is only realized when solar panels meet the grid and feed power to hundreds and thousands of load across the country. Due to increasing power demand, gigawatt level installations are becoming popular. However, the inverter technology used is more or less stagnated with only incremental changes in technology in last 10 years. It still needs to be connected to the low voltage grid, that is 230 or 400 volt, which is limiting the scalability, especially at the gigawatt levels. We are working on near future technology which would allow direct connection of solar inverters to 11 kilovolts grid. This would avoid use of bulky transformers, thereby reducing the size and cost of inverters, reducing their transportation and installation cost, and improving the overall efficiency. To achieve higher voltages, we are using silicon carbide based power MOSFETs. It's a relatively new technology, but a very promising one, and has the potential to dominate the solar inverter market. We at NCPRE are working extensively on this silicon carbide based inverter technology and the associated research challenges.
Welcome to the silicon solar cell fabrication and characterization facilities at NCPRE. Here we fabricate silicon solar cells on M2 wafers. Both aluminum BSF PERC solar cells have been worked on. Right now we are developing HJT and TOPCon technologies for perovskite silicon tandem devices. We also have extensive characterization facilities for characterization of various films, reflectance, and also IV, quantum efficiency, and so on and so forth. And these facilities have been also provided to industry. About 13 companies have used them for unit process development, assessment of solar cell technologies, and so on and so forth. Also used for development of silver paste, and about 40 students and staff who have been trained this facility have been employed in the silicon solar cell manufacturing in the country.
Current advancement in silicon PV technology is highly encouraging and is reaching its practical limit. For a further increase in energy generation per unit area, tandem solar cells are way forward. Halide perovskites as an emerging solar cell material holds a great promise for this tandem technology without adding any significant cost at the cell level. Forecasts suggest it can go to the LCOE at the level of 1 to 1.5 INR per kilowatt hour. A rapid improvement in the stability of this class of material is pretty evident, and the scalability is being addressed at the both academia and industry R&D. At NCPRE Hybrid Solar Cell Lab, we are able to make 4-terminal silicon perovskite tandem efficiency up to 29% with a bottom silicon close to 23%. We hope to reach beyond 30% within this financial year.